So we're going to learn about two things in this video. We're going to learn about solutions, and we're going to learn about something called solubility. So we've talked about mixtures before, and we talked about homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures can have another name, and those can also be called solutions. Solutions are specifically a liquid that contains a dissolved substance. So there's the liquid and there's the thing that's being dissolved. So there are two components to a solution, and they have specific names. The solvent is the most plentiful substance, so whichever one you have the most of, and it's the thing that does the dissolving. So traditionally in a solution, it's the liquid part of it. In what's called an aqueous solution, so that's a specific type of a solution, water is your solvent. So water's the thing doing the dissolving. The other piece, the solute, is what's being dissolved. So that's the thing that's the least plentiful. You can have solids, liquids, or gases as your solute. We're going to typically look at solids as our solute dissolving in a liquid solvent. Heterogeneous mixtures are not solutions, and we have two main types of heterogeneous mixtures that we're going to look at. The first type is called a suspension, and the second type is called a colloid. So let's look at suspensions first. The main difference between a suspension and a colloid are the sizes of the particles. So in a suspension, we have large particles. Gravity will cause settling, and they can typically be filtered because the large particles can get caught in the filter and you can separate the two pieces. So I want you to think and see if you can come up with any examples of a suspension. Some common examples that you might think of are salad dressing. What are some other ones? Paint can be considered a suspension sometimes. Anything that you can mix together and ultimately they have large particles and you can filter them out. So anytime that you have a solid that you're mixing with a liquid that if you shake it up, they mix together, but as soon as you let them sit, they start to separate. So in class, we've done a lot of decanting. That's a way to separate a suspension as well, because we let things sit, the solid sinks to the bottom, and then we can remove the liquid. Our other type of heterogeneous mixture is called a colloid. Colloids have medium-sized particles, so suspensions have large particles. Colloids have medium-sized particles, and then solutions have much, much smaller particles. Colloids can coagulate, so that means that they can clump together. They are cloudy when they're concentrated, and they're clear when they're dilute, or clearer when they're dilute. I want you to think of some examples of colloids. Some of the most common examples of colloids that you can find every day in your refrigerator are milk, whipped cream, and mayonnaise are all considered colloids. So they don't necessarily separate by gravity. When milk is dilute, it turns clearer. When it's concentrated, it turns cloudier. They can clump together, and so those substances meet our criteria for a colloid. We see colloids all the time. So now that we've talked about what makes something a solution, so remember it's dissolving, they have much smaller particles, they can't really be separated by filtration. Let's talk about something very closely related called solubility. So solubility is specifically the ability of a solute, so the stuff that you're dissolving, to dissolve in a solvent to make a solution. So not everything dissolves in water. If it can't dissolve in water, it is considered insoluble. If it can dissolve in water, it is considered soluble. Now that's specifically for water. Things can be insoluble or soluble in pretty much any liquid. Ethanol is one that you'll see commonly as well. If we can get something to dissolve, so if it is soluble in that liquid, there are three types of ways that we can describe that solution. The first is a saturated solution. That means that the solution has the maximum amount of solute that it can possibly hold. So you've dissolved as much as that amount of solvent can possibly hold for the solute. An unsaturated solution means that it contains less than the maximum, so you just haven't hit that maximum point yet. And then a supersaturated solution contains more than the maximum amount of solute in that particular amount of solution. Now, it seems like a supersaturated solution shouldn't be able to exist. Well, supersaturated solutions exist under very specific conditions. Typically, you have to heat them very strongly in order to get them to dissolve. And then once they cool, things start to solidify. Examples of this are if you've ever grown or made rock candy at home, you make a supersaturated solution. So you heat it up, you dissolve the sugar, you don't know what you're doing, but you're making a supersaturated solution. Then as it cools, that solid will fall out of solution because it's no longer soluble, and you get those pretty rock crystal candies. There are different things that influence solubility and how a solution is formed. The first is temperature, because we know that temperature increases the speed of the particles. Therefore, if the particles are moving faster, they're going to dissolve faster. Very closely related is pressure. If you increase the pressure, things are going to dissolve faster. That's how you get gases to dissolve in liquids. So when you open your soda can, it starts to get bubbly because your pressure has decreased, and therefore the carbon dioxide is coming out of solution and being released as a gas. People, when they make the soda cans, put it under pressure. They increase the pressure to force that gas to dissolve in the rest of the soda. The third thing is stirring. We all know that if we want something to dissolve faster, we stir it up because we're helping to break it apart. We're helping to expose the surface area to the surface area of the solute to the solvent. So that helps speed up the rate at which something will dissolve. Then there's particle size. We know that if we break things up into smaller pieces, they're going to dissolve faster. Again, that has to do with surface area. The greater your surface area, the more likely it is to dissolve, and the faster it's going to dissolve. And then lastly is something that we haven't talked about before called intermolecular forces. And that's what causes some things to be soluble in one liquid and unsoluble in another liquid, for example. And intermolecular forces are the attractions or repulsions between particles. So these are not bonds. These are not the attractions that hold a molecule together. These are the attractions or repulsions that separate molecules have for each other. And those types of forces can determine whether or not something will dissolve. If they have similar intermolecular forces, they'll dissolve. If they have different intermolecular forces, they won't dissolve. We're going to use something called a set of solubility rules to help us determine whether or not something's going to dissolve. And so solubility rules, they're just a very general set of rules or guidelines that help predetermine how a substance will dissolve. We're going to focus on things dissolving in water, and we're going to use our solubility rules to predict whether or not something should dissolve. And that's what we're going to do next. In this video, we're going to learn about concentrations and dilutions, what those terms mean, and then also how to calculate for concentration of a solution, and then how to calculate to do a dilution for a solution. So first, let's talk about concentration. Concentration is a word that we've heard a lot before, but let's put an actual definition with it. It's the measure of the amount of solute and solvent in a solution. Now, that's pretty broad because there are a lot of different ways that you can measure concentration. The way we're going to see it noted is like this. So whatever substance you're looking at, you'll see brackets around it. Brackets tell you concentration. So if I had brackets and then NaCl equals 4m, that would tell me that the concentration of my sodium chloride solution is 4 molar. And we'll come back to that a little bit later. But if you put brackets around something, that's telling you the concentration of that, at least for the molar concentration. There are 3 different main ways to measure concentration of a solution, and we're going to look primarily at the first one. The first one is called molarity. So that should tell you that you're looking at moles. Specifically, you're looking at the moles of solute divided by the liters of solution. So it's moles over liters, or moles per liter. The second way, and that one's noted by a capital M. So capital M means molarity. The second way is called molality, and that's a little m. And that's also dealing with moles of solute, but instead of dividing by liters of solution, you're dividing by the mass of the solvent. So molarity is moles of solute, liters of solution. Molality is moles of solute, mass of solvent. And then the last way that you often see concentration is a percent volume or a percent by mass, which is just like the percent of any other type of percent. So it's, in this case, your mass or volume of the part you're looking at divided by the mass or volume of the whole thing times 100. So that's your percent. And like I said, we're going to focus on this one right here. We're going to focus on molarity. So let's look at a couple of examples. So our first example says you have 3 moles of potassium iodide and 500 milliliters of water, and you want to calculate the concentration. Well, I know that my molarity is equal to moles of Ki divided by liters of H2O. Well, I already have moles of Ki, so that one's good. I have 500 milliliters of H2O, and I need that to be in liters. So I'm going to take my 500 milliliters. There are 1,000 milliliters in 1 liter, which gets me 0.5, oops, not milliliters, liters of H2O. And now my solution volume is in liters. So now we're good. So all we have to do to calculate molarity is divide. So molarity is 3 moles potassium iodide divided by 0.5 liters, which gets me 6. And then the units on that are capital M. And you read this as 6 molar. So this is a 6 molar solution. And you have to make sure that you put the M on it, otherwise that 6 doesn't mean anything. In this case, when we're looking at molarity, M is your unit. Okay, let's look at a second example. Our second example says we're dissolving 500 grams of sodium hydroxide in 2.5 liters of water. So if we want to calculate the solution of this guy, same thing. Molarity is equal to moles over liters. I have liters already, but I need moles, so I'm going to take my 5 grams of sodium hydroxide and convert it to moles. And in 1 mole of sodium hydroxide, there are 40 grams, which leaves me with 0.125 moles of sodium hydroxide. So now to calculate my concentration, molarity is equal to 0.125 moles divided by my 2.5 liters from my solution, which turns out to be 0.05 molar. Now, we did this as if we're calculating concentration for all of these, but really, if you know 2 of the variables, you can solve for the third. So if I gave you the concentration and the volume, you could solve for the number of moles. Or if I gave you the concentration and the number of moles, you could solve for the volume. It's just like any other equation. If you know all of the variables except one, you can solve for the missing one.